Hello viewers, in today's class we are going to discuss a very important and conceptual problem from differentiation involving the modulus function and the inverse trigonometric function, right? So in this lecture we'll find the derivative of this function, which is given as mod of x minus 1 multiplied sine of mod of sine inverse x at x is equal to minus half, right? So here we have to find dy over dx at x is equal to minus half, right? So this problem is going to be a very important problem, and this problem is very useful for the beginners, right? And if we try to solve these type of problems, then we can clarify so many concepts in mathematics, especially in differential calculus, right? So what we will do here, we'll try to redefine this function y as a polynomial function, right? So here we see that we have mod of x minus 1, right? So our first aim is to remove this sign of mod function, and we'll try to simplify this expression, which is sine of mod of sine inverse x containing the inverse trigonometric function, that is sine inverse x. And moreover, we have to see this point, right? So here we have x is equal to minus half, right? So what we will do, while redefining this function, we have to take care of this point, that is x is equal to minus half. So now let us first take mod of sine inverse x, right? Now from inverse trigonometric functions, we know that the principal value branch or the range of sine inverse x, it belongs to this interval, that is minus pi by 2 to pi by 2, right? So sine inverse x belongs to this interval, that is minus pi by 2 to pi by 2. So now here what we will do, we'll try to split this interval, right? So here we have 0, and here we have minus pi by 2, and here we have pi by 2, right? And here we'll also apply the uh, definition of mod function, right? So let us first define the mod function. So mod of p is defined as positive p when p is greater than 0, and mod of p is equal to 0 when p is 0, and this is mod of p is minus p when p is less than 0, right? So we'll make use of this definition of mod function to define sine inverse x or mod of sine inverse x in this interval, that is from minus pi by 2 to pi by 2. So now let us define mod of sine inverse x, right? So mod of sine inverse x is equal to a negative of sine inverse x whenever sine inverse x, it belongs to the interval, that is minus pi by 2 to 0, right? And mod of sine inverse x is positive sine inverse x whenever sine inverse x, it belongs to the interval 0 to pi by 2, right? So this definition of mod of sine inverse x shall be utilized in this function y, right? So now this definition can also be rewritten as mod of sine inverse x is equal to negative of sine inverse of x when x belongs to the interval minus 1 to 0, right? And mod of sine inverse x is positive sine inverse x when x belongs to the interval 0 to plus 1, right? Now let us redefine mod of x minus 1, right? Now mod of x minus 1 is positive x minus 1 whenever x minus 1 is greater than 0, and mod of x minus 1 is equal to 0, or when x minus 1 is equal to 0, and mod of x minus 1 is negative of x minus 1 whenever x minus 1 is less than 0, right? So let us rewrite this definition as mod of x minus 1 is equal to x minus 1 whenever x is greater than 1, and mod of x minus 1 is equal to 0 when x is equal to 1, and mod of x minus 1 is equal to minus x plus 1 whenever x is less than 1, right? So here we have solved these three expressions. So now using the definition of mod of sine inverse x and mod of x minus 1, let us rewrite this function y, right? So y can now be written as negative of x minus 1, right? See, here we have to find the derivative of y with respect to x at x is equal to minus half, right? So here x is less than 1, and obviously this point minus half is less than 1, right? So we'll make use of this definition of mod of x minus 1 as minus of x minus 1, which is equivalent to minus x plus 1, right? And here we have sine of mod of sine inverse x. Now mod of sine inverse x is equal to negative of sine inverse of x when x belongs to minus 1 to 0, right? And minus half, it lies in this interval that is minus 1 to 0, right? So minus half, it lies in the interval minus 1 comma 0. So here we have negative of sine inverse x, right? So now using some trigonometry here, we know that sine of minus theta is equal to negative of sine theta, right? So here sine of minus of sine inverse x can be written as, here we have minus x minus 1, and sine of negative of sine inverse x can be written as minus of sine and sine inverse x, right? Now this negative sign and this negative sign becomes positive when we multiply both the negative signs. We have y is equal to x minus 1 and sine of sine inverse x, right? Now let us apply some concepts from inverse trigonometric functions, right? Now from inverse trigonometric functions, we know that sine of sine inverse x is equal to x when this sine inverse of x, it belongs to this interval that is minus pi by 2 to pi by 2, right? Or in other words, we can say that x belongs to the interval that is the minus 1 to 1, right? And our x, that is minus half, it lies in this interval, right? So this is a very important point here, right? In fact, there are a lot of questions which can be asked related to this problem, but here we restrict ourselves to only finding out the derivative of this function with respect to x at x is equal to minus half, right? So at x is equal to minus half, that is uh, this point lies in the interval that is minus 1 to 1. So sine of sine inverse x can be written as x, right? So this quantity can be replaced by x. So we have now x minus 1, and here we have x, right? So now we can write x square minus x, right? So viewers, we have reduced our function y is equal to mod of x minus 1 sine of mod of sine inverse x to this equation or this polynomial, right? So this is a quadratic polynomial and it represents a parabola, right? And we see that y is equal to x square minus x is the equation of a parabola when x belongs to this interval, that is minus 1 to 0, right? Since x belongs to minus 1 to 0, the function is defined like this, right? So y is x square minus x, and our point minus half, it lies in this interval, that is minus 1 to 0. Now it is easy to get the derivative of y with respect to x. So dy over dx is equal to the derivative of this polynomial, that is x square minus x, so that is 2x minus 1, right? And here x is equal to minus half, so dy over dx at x is equal to minus half is equal to 2 times, and here we can take x is equal to minus half, and here we have minus 1, so 2 and 2 get cancelled, so we are left with minus 1, so this is minus 2, right? So viewers, the derivative of this function with respect to x at x is equal to minus half is equal to minus 2, right?